So the first question was the radius of a circle. They told me was 7. And the center of the circle I was given as -2, 5. And it says find the equation of the circle. Now, if we recall the standard form of the equation of a circle is x minus a squared plus y minus b squared equals r squared, where obviously r stands for the radius and the center is the point A, comma B. So if we know that the center is -2, 5, what we're going to be doing is x minus the -2, which becomes +2. In other words, we change the sign of the center, plus y minus 5 squared. That equals r squared, which is 7 squared or 49. So your answer, and this would be your answer in standard form, and that's what they're asking for. They're just asking you to give the equation of the circle, and the most convenient way is in standard format. Again, notice since the center was -2, 5, the numbers in the parentheses were +2 and -5 because it's x minus a and y minus b. So you have to switch the sign. Question number 2 said, find the center and radius of the circle x minus 1 squared plus y squared equals 15. So here it's just the opposite. They're giving us the equation of the circle and they want the center and the radius. So the center we know is the numbers inside the parentheses with the opposite sign. So the x of the center will be a +1. This really, they didn't put in the parentheses because there's really nothing next to it, which obviously means that it's 0. So the center of the circle is the point 1, 0. The radius of the circle is the square root of this number. In other words, this was 49 because the center was 7. So the radius happens to be the square root of 15. Usually this number is a perfect square, but if it's not, it would mean that your answer would be in decimals. But you can just leave it in what we call radical form. The radius is the square root of 15. If you checked your answers these are the answers that you would have gotten. Now, question 3, it says find the center and radius of the circle x squared plus y squared plus 6x minus 4y minus 12 equals 0. Now they're telling us find the center and radius, which means, of course, that we're dealing with a circle, which we would have known because we see this x squared and plus y squared, and their coefficients are both 1. That is the indication that you have this equation of the circle. Doesn't matter what else is going on. It's the x squared and the y squared that determine this is the equation of a circle. But this is not in standard format. So what we have to do is put this in standard format. And the way we do this is, number 1, we collect all the x terms. So we put the x squared and the 6x next to each other and leave a space. Then we collect the y terms. So we have a y squared minus a 4y. We also leave a space. And any number that doesn't have either an x or a y, in other words, any constant number, we just bring to the other side. So since this is minus 12, I'm going to have to do plus 12 to both sides. And this will give me 12 on this side. And then we use our method of completing the square on both the x and the y. So in order to complete the square on the x, I'm going to take the number in front of the x, which is plus 6, divided by 2. That'll give me plus 3. And then square it. 3 squared is 9. I have to add 9 in order to make these two terms to make the trinomial into a perfect square. Now, since I added 9 to this side of the equation, I've got to do the same thing on the other side. And then this particular trinomial, x squared plus 6x plus 9, becomes x plus 3 squared. It's the x plus 3 binomial squared gives you x squared plus 6x plus 9. Now you do the same thing with the y's. You take half of the number now in front of the y, which in this case is -2, and you multiply it by itself. -2 times -2 is +4. So you have to add 4 to the y squared minus 4y to make that into a perfect square trinomial. Of course, I added 4 over here. I've got to add 4 on the other side as well. And then this becomes the binomial y minus 2 squared. So now on the left side, we have x plus 3 squared plus y minus 2 squared. And on the other side, let's see what we have. We have to just add these all up. 12 plus 9 is 21, plus 4 is 25. We have now put this equation in what we call standard form, in that format that we have over there. And therefore, we can say what the center and radius is. The center, remember, you get from the numbers that are inside the parentheses. Next to the x is a plus 3, so the x center is -3. Remember, we switch its sign. Next to the y is a -2, so that becomes a +2. And the radius is the square root of this number, which happens to be a perfect square at this time, and the square root of 25 is 5. And that would be the answer to question number 3. So now let's look at number 4. Number 4 and 5 are also circle questions. Number 4, it says, find the center and radius of x squared plus y squared minus 6y equals 7. And we're going to have to do the same process we did with number 3. We get the x terms together. There just happens to be an x squared. Nothing else has to be done with it. Then we get the y terms together, which we have, y squared minus 6y. And we leave a space. And there's nothing to bring over because the 7 is already on the right side. And I do the same thing I did before. I complete the square. Now, I don't have to complete the square on the x because obviously this is really the x plus 0 squared. It requires no further work. But the y does because there is a y term, which we take the half of the coefficient. Half of -6 is -3. -3 times -3 is plus 9. So I have to add 9 to both sides. And then in standard form, our equation becomes x squared. This is y minus, minus 3 squared, and that equals 16. And now we see that the center of our circle is, well, there's nothing next to the x, so that's a 0. Next to the y is a -3, so that's +3. And the radius, the square root of this number, the square root of 16 is 4. There's a little less work because there really was no reason to do anything with the x because you had x squared alone by itself. And number 5, it says, again, find the center and radius, and here they're giving us x squared plus y squared plus 10x equals 0. And again, I bring the x terms together, so I have an x squared plus a 10x. And remember, I leave a space. Then I have a y squared. There's no plain y term, so the y squared is going to stay alone. And this is 0. And again, now we have to complete the square on the x rather than on the y. So half of 10 is 5. So this is going to become, and half of 10 is 5, and we have to multiply that by itself. 5 times 5 is 25. So I add 25 to both sides. So this becomes x plus 5 squared plus y squared equals 25. And now this is in standard form, so our center is -5. There's nothing next to the y, so that's 0. And the radius is the square root of this number. Square root of 25 is 5. So those are the type of questions you would be required to do for circle problems. Remember, we're dealing with the conic sections, and this is the first one that we discussed was the circle. So that is the way we would do these problems. Again, if you would want to draw any of these, all you'd have to do is go to a piece of graph paper, locate the center, and then count in up, down, left and right, whatever the radius is, and then just draw your circle. Okay, any questions about the circle? If not, I'm going to go erase this and go on to the next. Okay. So the next questions, we skipped questions 6, 7, 8, and 9 because those are on a topic we haven't covered yet. And the next questions we had were 10 through 17. So let me start with question number 10. I'm going to erase this side and leave that on for anybody who needs time to still copy. So number 11 says, number 10, I'm sorry, says find the intercepts and graph. And the equation they give us is x squared over 9 plus y squared over 16 equals 1. Okay, I'm now going to erase. This was the standard equation of the circle. Let's now talk about this type of equation. This is the equation x squared over a squared plus y squared over b squared equals 1 is the standard equation of an ellipse. And if you notice this, that's what this is in. It's x squared over one number, y squared over a different number. If these two numbers were the same, it actually would be a circle. And there's a plus in between them. And it has to equal to 1. So this is the equation. This is obviously the equation of an ellipse. We know that the a squared is what gives us the x-intercepts, and the b squared gives us the y-intercepts. The a squared is what's underneath the x squared, which means that the a squared in this case is 9. And that means a has to be either plus 3 or minus 3, plus or minus 3. My x-intercepts are either plus or minus 3. The b squared, the number under the 16, the number under the y squared is 16, which means the b is the square root of this number. It could be either positive 4 or negative 4. So my y-intercepts are positive and negative 4. And if I wanted to graph this, you know that you'd have to go 3 to the right and 3 to the left for your x-intercepts, 4 up and 4 down for your y-intercepts. And once you have these 4 points, you just connect them, and that gives you your ellipse. So that would be the answer to question number 10. Number 11 is again a similar question where it's asking you to find the intercepts and graph, but they're giving you an equation 4x squared plus 25y squared equals 100. Now, we will recognize this also as an ellipse because, again, we have this x squared and y squared term. Now, there are 3 types of equations that have x squared and y squared. We saw the circle, but when we had a circle, both the x squared and the y squared coefficients always were 1. They were both positive and they were both 1. In an ellipse, there's an x squared and a y squared term, but their coefficients are different. In this case, the coefficient is 4, and this is 25. Again, they're both positive. Notice this also is an x squared and a y squared term. If I ask you what is the coefficient over here where you have x squared over 9, remember that 9 is part of the coefficient. Your coefficient is 1 over 9. And here your coefficient is 1 over 16. Again, x squared plus y squared, but don't say their coefficients are 1 because they have numbers underneath it that are part of the coefficient. And therefore, it is an ellipse because we have different coefficients, but they're both positive. Now, in this case, when we don't have it written equal to 1, this is not in standard form. And if I want to graph an ellipse, I really want to have the equation in standard form. So the first thing is I look at the number on the other side of the equation. It's not equal to 1, so I divide by that number. If I divide 100 by 100, that'll give me 1. But of course, if I divide one side of the equation, I've got to divide the other side of the equation, which means I really have to divide every single term by 100. And now I'm going to simplify. Here, I can divide the top and the bottom by 4, and that'll give me, the 4 will cancel out, and I'll get a 25 on the bottom, which will leave me x squared over 25. Over here, I can divide top and bottom by 25. So the 25 cancels out, and 100 divided by 25 gives me 4. So that gives me y squared over 4. And of course, 100 over 100 is 1. So now I have this in standard format. Again, if you notice it, the numbers sort of switch. The 4 ends up on the bottom of the y squared, and the 25 ends up on the bottom of the x squared. That pretty much, I'd say in 99% of the time, that's what happens. And of course, now that we have it in standard format, I can do the same thing I did before. My a squared is 25, which gives my a to be either positive 5 or negative 5, so plus or minus 5. So my x-intercepts are 5 and negative 5. In other words, 5 to the right and 5 to the left. The b squared being 4 gives me b equaling positive or negative 2, which means the y-intercepts are 2 up or 2 down. And again, once you have those numbers, then you could draw your ellipse. I'm not bothering to do it because it's just similar to that, just the numbers that you go across. But notice, don't make the mistake of saying, oh, the x-intercepts are 2 and the y-intercepts are the 5. You have to have it in standard format before you can decide what your intercepts are. Now, number 12. So find the intercepts and graph of 2x squared plus 8y squared equals 32. And again, I recognize this as an ellipse because I have an x squared and a y squared term, but they have different coefficients, even though both coefficients are positive. And again, I want to put it in standard form. So this is 32. I'm going to divide everything by 32. And reduce the fractions. So here I can divide top and bottom by 32. So this will leave me 16. And here I can divide top and bottom by 8. And this will leave me 4. So my equation in standard form comes out to be x squared over 16 plus y squared over 4 equals 1. Notice this was a little bit more complicated or tricky because these numbers didn't just switch. But once you have it in standard form, you can again say, well, my a squared is 16. So my a, which are my x-intercepts, are either plus or minus 4. Here's my x-intercepts. And my b squared is 4, which means the b is either positive 2 or negative 2. So this is my x-intercepts, and this is my y-intercepts. And again, I go 4 left and right, 2 up and down, and connect my ellipse. So that was question number 12. Question number 13 says, the major axis of an ellipse is 10 and lies along the x-axis. The minor axis is 8 and lies along the y-axis. Find the equation of the ellipse. So let's just do a quick sketch of this. Here's my graph. The major axis is 10 and is along the x-axis. That means the whole length of the major axis going from one end to the other is 10, which means that you have to be going 5 to the right. In other words, to 5, 0. And you'd also have to go 5 to the left. Since the whole thing is 10, it means from the center it's 5 in each direction. The minor axis is 8, and that's along the y-axis. Remember, the major axis is the long one, the minor axis is the shorter one. Since it's 8, it means that you have to go up 4 and down 4, because again, it's 8 from tip to tip, so from the middle to the edge, it's 4. In other words, this is 0, 4 as 1 point, and this is 0, -4 as the other point. And here, this would be my ellipse. Okay, now they didn't ask me to draw it, they just wanted me to find the equation. Now remember, the ellipse is x squared over a squared plus y squared over b squared equals 1. The a is the x-intercepts, which could be either plus or -5, which means that the a squared has to be 25. It doesn't matter if you pick -5 or 5, when you square it, you're getting 25. The b is the y-intercepts. So my b is either plus or -4, which means that b squared has to be -4, or 4 squared, 16. And then I can just write my equation. X squared over 25 plus y squared over 16 equals 1. And that would be your answer in standard format. Just as an aside on this one, suppose they had given you that number 13 as a multiple choice. I'm going to erase this. And these are the, suppose they had given these choices. X squared over 16 plus y squared over 25 equals 1. 16x squared plus 25y squared equals 400. 4x squared plus 5y squared equals 20. And 25x squared plus 16y squared equals 400. And these are the choices they gave you. And you came up with this answer, x squared over 25 plus y squared over 16 equals 1, which is the correct answer, but they didn't give you any of those choices. How can you pick out the right choice? Well, it can't be this one, because we know the x squared has to be over the 25 and the y squared has to be over the 16. So I right away can get rid of choice 1. But the other choices are not in standard format. I would have to put these in standard format to see which is the correct answer. This one I would put in standard format by dividing everything by 400. And when I reduce this, the 16 goes into the 400 and gives me 25. The 25 goes into the 400 and gives me 16. And the 400 over the 400 gives me the 1, which actually gives me the answer that I wanted. This is not standard form. That was standard form, but this would be your correct answer. I really don't even have to look further. But if this wasn't correct, then I'd have to put this in standard form by dividing everything by 20. And if that wasn't correct, then I divide here this one. But people have a tendency to pick this one because they see the 25 with the x squared. But the 25 has to be under the x squared, not next to it. Again, it's sort of, the 16 goes under the, in this case, the 16 would be under the x squared, and the 25 would be under the y squared, which would be the same as choice A, and that would be wrong. This is the only correct answer. So that's something you have to be careful with. Okay, so that takes care of our ellipse, the questions on the ellipse. And the last type of example that we talked about was something called a hyperbola. We did very little with it. The hyperbola has a standard equation of x squared over a squared minus y squared over b squared equals 1. Now, in this case, the a and the b can be the same number. What's the important part is either the a and the b are the same or different numbers, but the signs of the x squared and the y squared terms are not the same. They're not both positive. One is going to be positive, one is going to be negative. Sometimes we have the x squared over a squared minus the y squared over b squared, or we sometimes have y squared over b squared minus x squared over a squared equals 1. In other words, it's not always the x squared that's positive and the y squared that's negative. Sometimes the y squared is positive and the x squared is negative, but one will have to be positive and one will be negative, and that'll be the indication that you have a hyperbola. So number 14, which they give as x squared over 16 minus y squared over 9 equals 1. What's interesting in a hyperbola is you don't get both x and y intercepts. When the y squared comes first, when the y squared is positive, then you end up with y intercepts and no x intercept. When the x squared is positive and the y squared is negative, then you end up with x intercepts and no y intercepts. So if I look at question number 14, where the x squared is positive but the y squared is not negative, I see that I'm going to have x intercepts. My a squared is 16. So my a will be either positive or negative 4. So my x intercepts are 4 and negative 4. There are no y intercepts. Also, sometimes written, the x intercepts are sometimes written this way: 4, 0 and negative 4, 0. Remember, when you have an x intercept, the y is always 0. And the way this would look, if we were graphing it, would look something like this. You go 4 to the right and 4 to the left. The hyperbola has two separate branches. This hyperbola will never touch the y-axis. It has no y-intercepts. It just has these two backwards, shall I call them C's? A little bit. Sometimes they are more curved, sometimes they're narrower, sometimes they're wider. But the big thing is there are these two facing away curves that cross at the x, at one at 4 and one at -4. And if you notice, there is no place where it's crossing the y-axis. That's what it would look like. And if you were doing a multiple choice, all you have to do is decide, because they'll give you two pictures where it's crossing the x-axis, two pictures where it's crossing the y-axis. So you only look at the ones that are crossing at the x-axis, because we know there are no y-intercepts. And then make sure that it's crossing. Oh, somehow I think I messed up on this. Here, 1, 2, 3, 4. 1, 2, 3, 4. It has to cross at 4 and -4. If we look at number 15, they're giving us y² over 25 minus x² over 4 equals 1. Again, we recognize it as a hyperbola because we have an x² and y², but there's a minus in between them. One is positive. Again, in this case, the y² is positive, and one of them is negative. And that means that we have y-intercepts and no x-intercepts. In other words, we determine which one gives us the intercept by the one that's positive. The -1 does not give us intercepts. If we tried to solve for the intercepts, I didn't go through the whole process, but it would end up giving you x² being -4, and that would be, x would have to be a 2i, and that you can't graph that, and that's why it has no x-intercepts. We find the y-intercepts by the same way. We know that b² is 25, so the b will have to be positive or -5, and my graph will look like this. 5 up on the y-axis for one intercept, 5 down. In other words, this intercept is the point 0, 5, and this is 0, -5. Remember, y-intercept always has its x value being 0. And again, we have these two facing away graphs, these two opposite, but now they're crossing the y-axis instead of the x-axis. Again, sometimes these curves open wide. They're sort of U-shaped, but sometimes you have a wide U and sometimes you have a narrower U. Again, that is a way, there is a way of determining how wide that should be, but that's beyond the scope of our course. This is all you have to know about the hyperbola. In terms of number 16, we were given that 16x² minus 9y² equals 144. I know it's a hyperbola because of an x² and a y², and one is negative. And that means that the x² is the positive one, means I'm going to have x-intercepts, but it's not in standard format, so I'd have to do what I did similarly with the ellipse by dividing by this to be in standard format. This has to be a 1, so I'm going to divide everything by 144. And reduce. 16 goes into 144 and gives me 9. 9 goes into 144 and gives me 16, and this goes down to 1. So this will be in standard format, x² over 9 minus y² over 16 equals 1. And that means I have x-intercepts of Since my a squared is 9, my a is going to be plus or minus 3. My x-intercepts are 3, 0 and negative 3, 0. Again, there are no y-intercepts for this one. And number 17 is similar, but you have to divide everything by 48. And if you divide everything by 48, you get x squared over 4 minus 16, y squared over 16 equals 1. And again, the x squared is the positive one, so there are x-intercepts, and they would be plus or minus 2. So that takes care of the 3 types of conic sections that we had discussed last week. And now we're going on to the last type. Is there any questions before I go on? Okay. So that was a very strong review of the conic sections that we had learned. And the last type of conic section that we are going to be looking at is something called a parabola. Now, a parabola is U-shaped. Usually, the parabolas that we talk about either open up. Notice, when I say they open up, it means that it's a regular U shape. No, also the sides keep going out further and further. They don't go straight up. They keep going, so it's not exactly a U shape. Sometimes it's an upside down U. Those are the ones we have to know, the type we have to know. It turns out you could have a parabola that is lying on its side. In other words, it opens either to the left or to the right. Again, there are these type of parabolas. We are not going to study these sideways parabolas. We're only going to do the up and down parabolas because, again, we don't cover this subject totally thoroughly. So we're going to look at these parabolas. If you look, it's not exactly, but if you think about it, the hyperbola is like 2 of these things facing away from each other. With a parabola, you only have one graph, one section. They're not 2 pieces to this graph. Everything is connected. It turns out that the standard equation for a parabola is y equals ax squared plus bx plus c. Now you're going to recognize something. First of all, that probably looks familiar to you. But in terms of what you have to do to recognize that what you're dealing is in a parabola, is if you notice, we have an x squared term, but there's no y squared. On the side ones, you have a y squared terms, but no x. In other words, the other 3 conic sections had in part of their equations both x squareds and y squareds. The parabola is the only one that doesn't have both the x and the y with squares. The up and down, what I call the up and down parabola, is the one that either open up or open down, are the type where the y is not squared, but the x is squared. Now, the A, B, and C just stand for numbers in front of the x squared, the x, and the c. In other words, I might have a parabola. Just getting some examples. Suppose I had an equation that looks like this. Y equals x squared plus 4x plus 7. Now I would right away recognize that this is a parabola because I have an x squared term, but there is no y squared. And I'd also know that this is an opening up or opening down, what I call a vertical parabola. Now what we're going to do is we're going to look to sketch these parabolas. And we're going to do that by finding three important things. If you notice the parabola, if I were going along this parabola, I'd be going down, 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 until I got to this point. And suddenly I'm turning around. In other words, this point happens to be what we call a minimum point of the graph. It's the lowest point of the graph. It's also sometimes called the turning point. A, it could be called the turning point. B, it could be called the minimum point. It could be called the turning point. And also sometimes the third thing it's called is the vertex. Probably this is the most common name for it, the vertex. But all these names indicate exactly the same thing. The point where this thing basically turns around. Notice this also has a vertex, the point where it turns around. Notice, since this is opening down, you're starting low and going up, 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 up. We're always talking as you go from left to right until you get to this point, and then you're going down. So this is also my turning point. Or my vertex. Or, now this is not a minimum point because it's not a low point on the thing, it's a high point. For an upside down parabola, the one that opens down, the vertex or turning point happens to be the maximum point. And if you think about it, when I draw the parabola, probably the most important point that I'd want to find would be this vertex. I'm going to call it vertex because that's more generic. But if I ever use the term maximum point or minimum point or turning point, you should know what it stands for. If I can find that and also determine whether my graph is an opening up parabola or an opening down parabola, I would have a very good sketch of my graph. So those are the first things we're going to look at. How to determine if a parabola opens up or down, and how to define the vertex. And actually, there are relatively simple ways. Number one, when the A, the number in front of the x squared is positive, the parabola opens up. When the A is negative, the parabola opens down. Easy way to remember that. Notice an opening up parabola looks like a smile. When somebody is positive, when they have a good attitude, when they're in a good mood, they're positive, they smile. When somebody is down, they frown. And they're in a negative mood. They don't feel like doing anything. So negative is a frown, opening down. Positive is a smile, opening up. So that's a good way to remember this. Notice in this particular example, The A, there is no number in front of it. Remember, the A is what we call the leading coefficient. It must be 1, and it happens to be positive. So this is an opening up parabola. The other thing we want to do is find the vertex. How do we find the vertex? Well, there's a formula. To find the vertex of a parabola, you use the formula x equals negative b over 2a to get the x value, and you find the y value by substituting into the number you get for the x into the equation. Let me demonstrate it with this example. Okay. And I'm erasing all these things because they're just taking up a little bit too much room. We'll redo this. So my equation that I'm working on is y equals x squared plus 4x plus 7. And let's write out what our A, our B, and our C is. For this one, the A happens to be the number in front of the x squared, which is 1. Then B is 4, that's the number in front of the x. Notice if there's no x term, then the B is 0. The C in this case is 7. If there's no number all along, that number is 0. Of course, the A is never going to be 0 because then if there's no x squared term, it's not a parabola. So sometimes you're missing an B, sometimes you're missing the x term, which means the B is 0. Sometimes you're missing the C term, which means the C is 0. In this case, we have both an A, a B, and a C. So if we want to find the vertex, we do x equals negative b over 2a, which is, my b is 4, so this is negative 4 over 2 times 1, which gives me negative 4 over 2, which is negative 2. Notice the formula that I gave you for the vertex doesn't give you the whole vertex. A vertex is a point you need both an x and a y. It only gives you the x or the vertex. To find the y, you take this number and stick it into the equation. You substitute negative 2 for x, so you're going to get negative 2 squared plus 4 times negative 2 plus 7. So this is negative 4 squared is 4 minus 8 plus 7 is negative 4 plus 7 is 3. So the vertex turns out to be the point negative 2, comma 3. So we found out 2 important facts. We found out that this is an opening up parabola because the A is positive, and we found out what the vertex is. If I were going to do a sketch of this, this is what I would do. I would go to the point negative 2, 3. So here's negative 2, positive 3, 1, 2, 3. And that is my vertex. And we know this opens up. So it looks something like this. Sometimes, most of the time, your parabola, if it opens below the x-axis, will cross the x-axis. If it opens down and it's above the x-axis, then it'll cross the x-axis. You first sketch it to see whether you have anything else that you can figure out. What are the other things that you might be interested in figuring out? Notice, I really have, if I were doing a multiple choice problem, I probably could just look at this and I could tell which of the choices would be the right choice for the graph. Knowing whether the parabola opens up or down and knowing what point is its vertex gives you a very good sketch. Other things you might be interested in finding are the intercepts. Now, if I look at this, there actually are no x-intercepts. Since this is an opening up parabola, it has a minimum point. The minimum point is -2, 3, which means it's above the x-axis. And therefore, it's not crossing the x-axis at all. It has no x-intercepts. But it does have a y-intercept. So it has no x-intercepts. To find the y-intercept, because that'll give me a better idea of whether this should be higher or lower. The way you find a y-intercept is replace x with 0. Okay, so go to your equation, and wherever you see an x, put a 0. So this will become 0 squared plus 4 times 0 plus 7, which obviously just gives you 7. So the y-intercept is the point, x is 0, y is 7. Now notice if I then go here, 1, 2, 3, 4, 5, 6, 7. If I put that in, it gives me a little bit more of an indication. And then once I've gotten one side, I make the other side sort of equivalent. I made it a little too wide. It should have been a little bit narrower. So finding the intercepts can give you a better diagram of your parabola. I'm going to do one more, and then I'm going to give you a chance to try one. Okay, so let's do one more example. Suppose I give you this, y equals -2x squared plus 8x plus 3. Actually, you want to do okay. I think this is not going to be such an easy one, but I'm going to do a complicated one. I'll give you one that's easier to work out yourself. A, I know this is a parabola. Why? Because I have an x squared term in my equation, but I do not have a y squared. I also know that my a happens to be -2, which means that this parabola has to be an upside down parabola. A is negative, this is a frown. Okay, let's find the vertex of this parabola. Okay, the way we find the vertex again is we do x equals -b over 2a. Now in this case, my a is -2. My b happens to be +8. My c happens to be 3. So this is going to be -8 over 2 times -2. So it's -8 over -4, which gives me +2. The x of my vertex is 2. But I also have to find the y of the vertex. To find the y of the vertex, I stick sorry, I just muted everybody. We put the y equal to, we'll replace the x with 2. -2, here's my x is 2 squared, plus 8 times 2, plus 3. Now you could do this on a calculator, but I'm going to do it in my head. Remember, when you're doing something like this, you first square. So 2 squared is 4. And I have to do -2 times 4, which gives me -8. Remember, only the x is squared. So you only square the 2. You do not square, you don't multiply first -2 times 2. Order of operations. Then you do 8 times 2, which is 16. And then you do plus 3. And when I add these all together, I get the number 11, I think. Let's see. -8 plus 16 is 8. 8 plus 3 is 11. In other words, my vertex is the point 211. And there might be a question, just what is the vertex of this parabola? The answer would be 2, 11. Notice when I go to draw it, if I wanted to draw this, I go up over to 2 and up 11. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. Here's my vertex. I know it's going to be an opening down parabola. Let's see if we can also find the intercepts. Okay, the easier intercept to find is always the y-intercept. And you do that by replacing in your equation x equal to 0. This is general. Whenever you want to find a y-intercept, we've done it with lines. You could do it with any graph. To find a y-intercept, go to your equation and replace it with 0. If I do that, I'll get y equals -2 times 0 squared plus 8 times 0 plus 3. All these are zeros. It just gives me the 3. In other words, in general, the C is the y-intercept. The y-intercept is the point, 0 is the x, 3 is the y. If I wanted to draw it on my graph, here it would be 1, 2, 3. Which means that my graph would look like this. Notice I draw one side and then I draw the other side. Symmetry, symmetrical. It looks the same. The line down the vertex, straight up and down in the vertex, is what we call, I know this looks like it's sort of sideways, but it's should look the same on both sides. It should be a hill that's perfectly symmetrical on both sides. This is so lopsided, I'm sorry. Notice this particular parabola was much thinner, was much narrower than the parabola that we did before. And actually, I knew that would happen because the A, forget about its sign now. The sign tells you that it opens down, but the size of it affects the width of the parabola. When the number A is a bigger number, just looking at the absolute value of it, not at its sign, just at its value, the larger it is, the narrower your parabola is. If this would have been a 1/2, then I would have had a wider parabola. The standard size, of course, is when the A is 1, and that's the regular size. Notice this would have been enough for me to graph it, but I did notice also that this parabola is crossing at 2 points. Usually that's what happens. Not only you'll only get one y-intercept, but you very often get 2 x-intercepts. The question before had no x-intercepts. Occasionally we only have 1 x-intercept, but the most common situation is in a parabola that you're going to get 2 x-intercepts. The question is, how do you figure out where this x-intercepts? What if the question was not only graph it, but find the intercepts? So we found the y-intercept. How do we find the x-intercepts? Well, we found the y-intercept by replacing the x with 0. We know this. We did this with lines. To find an x-intercept, we put y equal to 0. You do just the opposite. Whenever you have an equation of a graph, you want to find its x-intercept. In your equation, put in the y equal to 0. You want to find a y-intercept, put the x equal to 0. Now look what happens when I put x equal to 0. When I put the y equal to 0. I get the equation. Let me go over here. The equation that I'm going to get is, in place of y, I'm putting 0. 0 equals negative 2x squared plus 8x plus 3. Now, I always like to have my x squared term positive. This is a quadratic equation, but the coefficient of the x squared is negative. Now, I can't do it when I have the parabola because it's not equal to 0. But when it's equal to 0, I could just bring everything to the left side. In other words, add 2x squared, subtract 8x, and subtract 3, so that we end up and do the same thing over here. So that we end up with the equation 2x squared minus 8x plus 3 equals 0. In other words, when we want to find the x-intercepts of the parabola, we end up with a quadratic equation that we have to solve. Do we know how to solve quadratic equations? Well, that's why, if you notice, each time we went to another chapter, we sort of built on what we learned before. We just had a whole chapter on how to solve quadratic equations. So we know how to solve this quadratic equation even if it can't be factored, we could use either the quadratic formula or the um, completing the square method. Actually, I wouldn't want to use the completing the square method on this one because there's a number in front of the x squared. So let's solve this quadratic equation. It's a good test. Obviously, on a final exam, they're not going to give you something as complicated to do, graph the parabola and also solve quadratic equations. It could be two separate questions. It could be find the x-intercepts of this parabola. And that would mean you'd have to solve this quadratic equation. So I'm going to erase everything and go to that equation. The equation that we have is 2x squared minus 8x plus 3 equals 0. And I want to use the quadratic formula to solve it because I think it's good practice for us to know that also. Remember, in this case, since it's not the same A and B and C that it was for the parabola because I've moved things around. I brought things from one side of the equation to the other side. So therefore, my A in this case turns out to be 2. My B turns out to be negative 8. And my C turns out to be 3. No, I'm sorry. I think this C turns out to be negative 3, right? This is supposed to be a negative 3. Should be a positive 2x squared, a negative 8x, and a negative 3. I think I made a mistake there. And my quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to substitute these numbers. So my x is going to be, here's my b, negative 8 plus or minus, here's my square root, it's negative 8 squared minus 4 times 2 times negative 3 all over 2 times 2. And we simplify. Negative and negative gives me positive 8 plus or minus. Okay, here's where we have to be careful. Negative 8 squared is 64. Minus 4 times 2 is minus 8. Minus 8 times minus 3 is plus 24. So we get 64 plus 24, which gives me 88. And over 4. Now, if I wanted to do this for graphing, I would probably, 88 is not a perfect square. So I would probably want to use my calculator to find the number in terms of decimals because I can't graph radicals on my graph. I can graph decimals. So here's my calculator. I'm going to do the square root of 88. And it comes out to be approximately 9.4. So this becomes 8 plus or minus 9.4 over 4. And my two answers are 8 plus 9.4 divided by 4 for one answer, 8 minus 9.4 divided by 4 for my other answer. So 17.4 divided by 4. This gives me 4.35 or 4.4. Negative 1.4 divided by 4 gives me negative 0.4. Now, of course, I erased what I had before. I want to show you how this would have gonna help in graphing this example. We had before that the vertex was the point 211. Here's my 211. We also said that the y-intercept was 3. Now this was the point 0.03. That's what we had before. Now we're going to put on these two numbers. We're going to go to 4.4. Here's the x. 1, 2. Here's 1, 2, 3, 4, 5. It's approximately halfway. And also to -1. So we go, here's 0, -1. So it should be approximately here. And if I connect all these points, I'll get a very good graph of the parabola, better than what I had done before. So this is what it means to totally solve a parabola. Again, this was a very difficult one because we had to find the x-intercepts, the y-intercept, and the vertex. And finding the x-intercept found a long problem. But this is what you might encounter. You wouldn't have to do all of this, but some of this you might be asked to do. So let me give you a question. I'm going to erase this now, and I'm going to write a question on the board. I'm going to give you a few minutes to do it. You have about 20 minutes left to class, so you will have time to do this. I'll give you about 6 or 7 minutes, and while I do that, I'll take attendance. Here's the problem. I want you to sketch this parabola. It's y equals x squared minus 2x minus 9. Okay, and I definitely want you to find the x at the vertex and the y-intercept. If you can find the x-intercepts, that's an extra. In a little while, after I take attendance, I'm going to put on the board sketches, and you're going to have to pick the correct sketch. Okay, so I'm going to give you time now to work on this problem. Okay. Oh, let me put the, and we were supposed to pick out which of these is the correct picture. Now, I right away can eliminate picture C. How do I know that I can eliminate C? Because C is an upside down parabola, and an upside down parabola always has an A. The number in front of the x squared would have to be negative. So right away, and this is, not only I'm going to demonstrate how I do problems when you have multiple choice. If you can eliminate some of the answers, and you don't know if you have to pick between 2 rather than between 4, then you're in a much better shape because you're more likely to pick something right if you only have 2 choices rather than 4. So anytime you can eliminate a choice, that gives you a better chance, even if you don't have, let's say you're running out of time, you know that right away you would never pick choice C. Okay, what we want to do is find the vertex and the y-intercept, because once we have that, we can really do a pretty good sketch of the graph. So to find the vertex, we know we have to do x equals negative b over 2a. And the a in this case happens to be 1. It's positive. We know it's opening up. The b happens to be negative 2. The c happens to be negative 9. So the x of the vertex will be negative 2 over 2 times 1, which gives me negative and negative is positive 2 over 2, which gives me 1. The x of the vertex is 1. To find the y, we stick it into the equation. We have what x is. We're going to replace the x in the equation with 1. So we're going to have 1 squared minus 2 times 1 minus 9, which is 1 minus 2 minus 9, which gives me negative 10. My vertex is the point 1, negative 10. Now, if you look at it, it can't be this one, because this looks like it's 1 but positive 10. That's wrong. This is negative 1. The vertex is to the left of the y-axis, so it's not this one. And here we see 1, negative 10. My vertex is the point 1, negative 10. You're right, it has to be choice D. I didn't have to figure out what the y-intercept is. I didn't have to figure out what the x-intercept is. But they could ask me those questions. The x-intercept is more difficult, but to find the y-intercept is usually quite simple. You just replace the x with 0. And when I do that, I get y equals 0 squared minus 2 times 0 minus 9, which this is 0, this is 0. This gives me negative 9. Just like I said before, usually the c value gives the, and that's right here over here at negative 9, because here was a negative 10 and it was a little bit above that. So it looks like we've done this correctly. But again, just looking at the vertex and the fact that it opens up was enough to help me figure out which of these graphs would be the correct choice. Does anybody have any questions about this now? Okay, Nikisha and Carmelita, you did great. Okay, your homework, I will be giving you some homework on Delta Math, but from the your homework for Thursday will be to do examples 6 through 8 on the exercise sheet, on the chapter 9 sheet. Again, also look for anything on Delta Math. There aren't a lot of questions on this topic in Delta Math, so that's why I've been giving you the homework from here, but you will be able to find some there are some questions, so do look on your Delta Math. Don't forget to complete that Delta Math test today if you want full credit. Again, I'll say it one more time. If you have not completed all your homeworks or all your tests, I have opened them up. There is a slight penalty for doing them late, but you get credit for doing them late. So it's better to get 90% credit than 0% credit. So if you go back and look at yourselves and you see a 0 by something, or you know you haven't done something, make sure that you get it done. If you did not do the midterm, you must send me an email and I will open it up personally for you to do that midterm. I am not automatically opening the midterm for everybody, but if you didn't get a chance to do the midterm and you do want to do it, again, you won't get full credit, but you'll get most of the credit. Make sure you get your homework done. We only have, after this, we only have 5 more classes after this, and I will send out around before the end of November, but probably towards the end of November, I'll send you out, each one of you, an indication as to whether you are missing anything and whether you're getting most of your credit. Again, you can see on your Blackboard account what your averages are on the tests. I haven't put on, obviously, this last test, but I have 4 tests are already listed on your Blackboard account: the midterm, the 2 Delta Math tests that we've had previously, and the practice midterm, which was also considered a test. So if you want it, you can see your marks on that, so you'll know where you're standing. Have a good day. I will see you on Thursday.